Hello, candidates. Very good evening. This side Ankit. I hope I'm audible. And let me just share my screen. So, candidate, how are you, all of you? I hope I'm audible and my screen is visible too, right? So, can anyone kindly confirm me so that we can continue, right? I have I have shared my screen and just let me know my screen is visible or not, right? So, let me just open Colab. And guys, today we are going to start with unsupervised machine learning, right? So quickly just confirm in the message box, then I'll continue with the same, guys. Hello candidates, Vijay, Spurti, and the other candidates. Guys, am I audible now? Just let me know. Okay, got it. Perfect. So in the last class, we have already covered the topics related to unsupervised machine learning, right? That was just a kind of introduction. So what we are going to understand, we'll start the unsupervised machine learning in deep, and then we'll finally create a project once we complete this unsupervised learning, right? So let me just open a new notebook in Drive. And we know that unsupervised machine learning is completely based on the X data set, right? We don't have any Y set of data set, okay? So let me just start this from basic. Okay, so today we'll start the unsupervised machine learning. Okay. Now, what exactly? In the last class, I have already introduced the things that unsupervised machine learning is something where we'll not get the label data set, right? Whatever the data set that we'll get is completely based upon the features. This is the main problem with the actual scenario. So in the supervised machine learning, we have sort of, let me just write this, in the supervised machine learning, we have different features. The features are like F1 features, F2 features, F3 features, F4 features, and so on to up to Fn features. And based on all these features, we generally refer these features as x1, x2, x3, and xn, right? And with this x1 multiple features, we have some sort of y target values as well, right? That is output value. We have to predict some outputs, right? And the outputs are like y1. We are not getting the multiple outputs, so that is the reason I am just simply considering this as a y output, right? So this is called my supervised machine learning. But what about the unsupervised machine learning? In this unsupervised machine learning, we are only having these multiple features like feature 1, feature 2, feature 3, and up to feature n, but we don't have any y data set. And that is the reason we are saying this. We don't have any kind of supervision here where no one is going to tell you like this is the output that we need to predict, right? We don't have to predict any output. We have to classify the groups. We have to create some sort of clusters. Okay, so let me just write this. We don't have any output or labeled y data set here, right? We don't have any labeled y data set here. So what we just want to understand the patterns of our underlying data set, and based on that pattern, we just simply create a clusters of all these data set. Okay, so let me just write this. In this unsupervised machine learning, in unsupervised ML, we have to divide the data set into different clusters, right? And these clusters are generally referred as a groups, right? We have to take some decision based on the available data set or available patterns, and based on that pattern, we have to just simply group them all together. Like this belongs to cluster 1, this belongs to cluster 2, and so on. Okay, let me just take an example for this, right? Suppose if someone is watching the reel and the kind of reel that they're watching is like sad kind of reel, right? So when they scroll to the next reel, they'll get generally suggestion of a sad reel, right? Because whenever the person is scrolling that reels now, so the Insta algorithm somehow got to know that, okay, right now the mindset of this person is like sad kind of reels, right? So let's just suggest the reels that generally match with their mindsets, right? So Insta algo will be like, it will only suggest the sad kind of reels, okay? Because that particularly mindset is somehow belongs to the group of that clusters, right? So whatever the content that fall inside that cluster will be suggested to that particular user, right? So that is the reason we are creating clusters here, right? Let me just show this with examples. Okay, Suppose I have some sort of this data set, right? Where I am getting the x-axis and like the spending score or like the salary we have, okay? And at the y-axis, I'm getting the, I have already used this as example in the last class, but I'm just quickly giving the same reference, right? So these are the spending scores, right? Now we have some sort of different potentials customers or like low potentials customers as well, right? There might be chances the customers are like having low salary scores and low spending scores as well, right? These are my low targeted customers, right? What about this one? This one is like the customers which are having the high spending score, but they have their low salary structure or like low salary scores, right? What about these customers? These customers are kind of which are having the high salary, high monthly salary, but low spending scores. And what about this one? These one are like the customer having high salary and the high spending scores as well, right? Suppose you have launched any sort of like new products in the market, and what you just want to run your advertisement. Okay, you are working as a digital marketing kind of analyst, some sort of, and your company launch a new product, and the product is some sort of product X. Okay, now you just want to run an advertisement over this product. So what kind of potential customer will you probably choose for your advertisement stuff, right? You will definitely choose, I think, this cluster. This cluster you can probably choose. Why? Because these are the customer that they have high salary structure and high spending score. If you just feed your reel, or if you just quickly like forward your advertisement or suggest your advertisement to that kind of clusters, then the potentials of buying that products quite on higher side. You can say that, right? Because the customer are having the highest salary as well as the highest spending score, right? So you will choose that cluster. And how you got to know, okay, this is a cluster? Because some sort of analysis you have performed, and that is called unsupervised machine learning, where we are just simply creating the clusters or like the groups, and there is no such Y level data that we need to predict. This is the cluster one. We have particularly picked that one as per our based patterns, right? Whatever the patterns we have, right? And you can show your advertisement to this kind of potential customers as well, right? They are having the salary on higher side, but the spending score is very low. And you can pick that customer also with a huge discount because they have the low salary structure, but the spending score is very high. So you can feed your advertisement, or like you can quickly show advertisement to this kind of customers because they have the potential to spend much, right? So how do you got to know that, okay, this kind of clusters, and we can probably select the clusters based on the product requirement, right? So that is a part of unsupervised machine learning. In unsupervised machine learning, we generally have the X data set, and we simply convert all these features into two-dimensional array, and then finally you have to convert all the data set inside the clusters, and we generally refer these clusters as a group of data, right? And all these clusters are like having the same common pattern. What exactly the common pattern between all of these? They are on the highest spending score side, right? And what about these are? These are like the low spending score with the highest salary. So if some features have some potential features, so you can just create a cluster for that, right? So these are the clusters. And in industry, if we generally work, so sometimes we generally refer this as a team or like a group, or like a kind of some sort of same frequency matching candidates, right? So these are something like the group of people, or like a group of set of data, or like a set of clusters you can refer, right? This is called unsupervised machine learning. So we have multiple examples that we can generally refer in this unsupervised machine learning. I have already explained this in the last class, right? Candidate is, if there is any YouTube video suggestions now, this YouTube video suggestion is generally like can be done with the help of unsupervised machine learning. YouTube videos recommendation, okay, Insta reel recommendation, all these are part of this unsupervised machine learning, right? Movies recommendation, okay. If you're using Netflix so much, if you like more inclined toward the horror kind of or like action kind of movies, so the company or like the Netflix analyst, we generally suggest you the action type of movies or like the horror kind of movies, because you are quite interested in that kind of movies, because you fall under that cluster, you fall under that categories, right? So movies recommendation or like movie suggestion is also a kind of this problem that you can probably solve with the help of unsupervised machine learning. Guys, I hope everyone is getting my point, guys. Is there any doubt, candidate? Just let me know in the message area, candidate. It's good to go, I think, right? So if you're getting any sort of problem now, like this one, so directly you can use the unsupervised machine learning. And why we're saying this unsupervised? Because there is no there is no Y data set that generally supervises. So we are only having the features. And based on that features, we need to probably classify, or we need to create a clusters. And clusters are like just nothing, a group of data set. This is cluster 1, cluster 2, cluster 3, cluster 4. You can say this as cluster 1, cluster 2, cluster 3, cluster 4. Even you can start with this one, cluster 1, cluster 2, cluster 3, cluster 4. There is no such permanent fix like this is the cluster 1 only, right? But whatever the clusters that you are generating or like giving that, so it is particularly belongs to the same features, right? And that is the main task of a supervised machine learning, right? Now let's just understand this with different scenarios, right? Guys, just let me know if like we have some sort of like X and Y correlation, and the data set that we are getting is some sort of like this one, okay? We have the data set like this one, okay? And some features are like somewhat here, right? Okay. Now just quickly let me know, based on your analytical thinking, right? How many clusters do we generally required to create a set of like clusters or like a group? Just let me know in the message area. If I'm plotting any data set, right, the feature could be anything, X feature and Y feature, but after plotting those X and Y feature, I'm getting some sort of visualization like this, okay? Now just let me know, I have to create a clusters. Just let me know how many clusters are required. Guys, can it quickly give an answer in the like message box? How many clusters do we generally require here? I think 2 clusters is enough, right? Because you can just say that now this is like your cluster 1, it's like a group 1, and this is like your group 2. But why you are considering this as a 2 cluster? Can we not like simply say this, okay, this is also like my cluster 1, okay, this one is like my cluster 2 as well, okay, and that one is like the cluster 3, same as it is, this is like cluster 4, and these are like the rest cluster 5, and so on, cluster 5, cluster 6, and let me just make it cluster 7, right? Okay, so you can just say that now why we are simply picking the cluster 1 and 2 only. So it's completely based upon the overall pattern or like overall distribution of the data. If we are creating individual cluster or like many clusters, so this could lead to a problems, right? The problem is like we are not able to easily categorize the data, we are not able to easily classify or like group the data. So it's very important to identify the number of clusters. Right now you can just say that I think 2 cluster is enough, right? The first cluster is this one and second cluster is this 2. Okay, so getting the cluster is generally represented by the value of k. If I am creating 2 clusters, so I can simply say this, the value of k is 2. It's like we are creating 2 clusters. Now, what is the value of k here? The value of k here is 4 cluster. We are creating the 4 cluster. Okay. Now, again, let's just take another example. Okay. Suppose I have this set of data set, and you have to just let me know how many clusters are required, right? The data set are like this one. Okay. These are like some sort of this data set. Okay. And let me just quickly make this like this one. Okay. And let me know how many clusters are required, candidate. Is there anyone like would like to answer, candidate? How many clusters are required in this particular data set? Right now, we are easily able to identify, okay, we have 4 different set of groups now. So let's just quickly make this as a 4 clusters. And here you can also easily identify, okay, we are somehow able to take some sort of distance consideration. These are like some set of separates group. So let's just make this as a cluster 1 and cluster 2. Now, what about this one, guys? Is there any idea like how many clusters are required? Can anyone wants to let me know, guys, how many clusters that do we require here? Guys, anyone wants to say something? Guys, so can I just say that we can create either 2 clusters as well, 1 clusters, or 3 clusters as well. Let me just make this. If I simply consider this as a cluster 1, this one is as a cluster 2, and that one is like the cluster 3. So we are considering this as a 3 clusters set of solution. Now the value of k becomes 3. Okay. But what about this one? Instead of 3, can I just simply say this? This one is like my cluster 1, okay, and this one is like my cluster 2. Now the value of k becomes 2, okay, candidate. Now you can easily say this, okay, this one can also be the cluster A, okay. Let me just make this right. Instead of taking a circle, can you just say this like this is your cluster A and this one is your cluster B, right? You can also say this, right? So we somehow we need to identify like how many, like how to easily identify the patterns, right? And what exactly the value of k should be. If I'm considering the value of k1, so you can just say that, okay, you can simply take this as a cluster 1 instead of creating multiple cluster. It just create this as a cluster 1, right? So it's very important to understand the value of k. If you are particularly considering the wrong value of k now, you will probably end up with the wrong clusters. So I think right now it's easily to pick two clusters. The one can be represented by this one, like the cluster 1, and second can be represented by this as cluster 2, right? So it's very important to understand what should be the ideal value of k, right? And once you good to go with the ideal value of k, then you can say that, okay, now we can simply categorize this data set into two clusters. The first one that belongs to this cluster and second one that belongs to this cluster. So it's very important to finalize the value of k. I hope everyone is getting my point, candidate, right? Can anyone just let me know in the message area? I hope it's important to understand the value of k here, right? If we are considering the value of k as 3, so we probably end up with 3 clusters, right? So how to quickly identify or to understand what should be the optimal value of the k? So for that kind of consideration, you have to understand different set of unsupervised machine learning, right? So now let's just understand different types of unsupervised machine learning. So in the unsupervised machine learning, you know that we have to create a clusters, right? Now let's just understand the actual different types of unsupervised machine learning. The first one is very popular, which is generally say this as a k-means clustering, right? The second one is called the hierarchical clustering, and third one is like the DBSCAN clustering, right? So let's just understand this one by one, right? The first one is k-means clustering. Second one is like the hierarchical clustering. Hierarchical clustering is further divided into two parts, okay? You'll probably understand this, right? And the third one is the DBSCAN clustering, right? Now let's just understand first with the k-means clustering, okay? The second one is the hierarchical and the third one is DBSCAN clustering, right? Let me just comment this out. And the third one is the DBSCAN clustering, okay? Now, what exactly this k-means clustering is? So we know that now we have to identify the value of k. So this k-means clustering is completely based upon the centroid concept, right? Now let's just understand what exactly this k-means try to understand, right? So what I'll do, I'll quickly ignore all the features and let's just delete this, and I'll simply create it from scratch, right? And what I'll do, I'll just simply create the set of data set like this one. This one is like my data set 1, and that one is like my data set 2. Okay. And this one is like my data set 3. Okay. Now the k-means that we are considering is completely based upon the value of k. Okay. And means is like we have to take a mean or average of distance from a given random centroid. Okay. Now let me just quickly explain this. What is the meaning of this, right? In this k-mean, we have to take a mean or average of distance from a given random centroid, right? Now, in this k-means algorithm, what we'll try to understand, candidate, we'll simply initialize some random points, right? And let me just initialize the random point here, right? And this random point generally referred, all these random point are called the centroid, right? So what we'll try to understand, we'll simply initialize the random points, one random points here and one random points here. It can be like this one also, and it can be like this one also. Okay, let's just change the color of this, like this one. Perfect. Now, once you initialize the random points, so you will try to identify or you will try to calculate the distance between the given values, right? If you have just simply randomly initiated this, so then you will probably calculate the distance. So the distance, you will use the distance formula, and you know that you have two distance formula. The first one is called the Manhattan distance, and second one is called the Euclidean distance, right? You already know that, candidate. If you want to calculate the distance between two coordinate, like two points on a given coordinates, so you can use two set of distance concept. The first one is called the Euclidean distance, and second one is like the Manhattan distance. Okay, so Euclidean distance is the formula remain like this. I hope everyone remember this, right? Underscore under root x2 minus x1 square, and then plus y2 minus y1 square. I hope everyone knows this formula, right? If you are familiar with the KNN algorithm, so this KNN algorithm is completely based upon this Euclidean distance, or like the Manhattan distance. Okay, so distance is like x2 minus x1. X2 and x1 are like the coordinates, right? X2 minus x1 square and plus y2 minus y1 square, and these are like the distance. So you will randomly initialize the value, and then you will probably calculate the distance. Okay, and then you will take a mean of this. Okay, mean is like the average distance of all this, right? Once you take the average distance of all these things, right, then you will simply, once you take an average of this now, and you will got to know, okay, the average value is some sort of like this, any xyz value. So then you will probably move this centroid towards their mean value. It's like whatever the average value we will get, we just simply try to move this centroid. So let me just erase this. If we got any like mean value now, whatever the average value that we'll get, we'll just simply pick that centroid, and we'll simply move that centroid. We'll, instead of this now, we will move this centroid like this to their centroid. Okay, like this one. Okay, let me just move this like this one. You can you move your centroid like this. Okay, you, how to move this centroid? You have to take an average of overall distance. And how to check the distance? You can use the Euclidean distance and the Manhattan distance. Let me just show this. You have two different types of distance. The first one is called L1 distance, and second one is called L2 distance. Okay, L1, L2 distance are like Manhattan distance and the Euclidean distance. The L1 distance is like Manhattan distance. Okay, if you want to go from this point to this point, now from this point to this point, you can take the this distance also. It's like base plus perpendicular. This is called Manhattan distance. And if you want to directly go to from here to here, you can take the hypotenuse distance. So it's like the Euclidean distance, and we refer this as a L2 distance, right? And right now we are using the L2 distance instead of L1 distance, although you can use L1 as well, right? So whatever the distance that we got, candidate, we'll try to move that centroid, whatever the random centroid that we have initialized, we'll move that centroid towards its mean value. So let's just move this centroid from here to here. In the same way, we will repeat the step of this centroid, like whatever the centroid that we have just created, we'll again calculate the distance, and then we will move that particular centroid somewhat here. Same way, we will do the same thing with this one, right? We will again calculate the distance of each of the points of the given data set, and then we will move the centroid towards its mean, right? Whatever the mean value. See, if we calculate the distance now, we'll probably get the average distance, and we will move that centroid towards their average value, right? Now, once we repeat this iteration multiple times, then if the centroid reaches to its median or like the mean value, then you can probably refer this as a cluster, right? This is your cluster 1, and this is your cluster 2, and this is your cluster 3, right? So in this way, that is the reason we are saying this as a K-means. Now in this, you know that, candidate, means is like you have to calculate the mean distance, and you have to move your centroid, randomly initialize centroid towards their mean. That is the value of this mean. Now what about the value of K? The value of K is like how many centroid like you will initialize. If you will initialize 2 centroid now, so the equation or like the cluster will become like this. Let me just remove all the things, and the cluster will become like this one. If you have initialized 2, value of K as 2, so the centroid will be like this. This one is like centroid 1, and this one is centroid 2. Okay, once you move this centroid towards their mean, right, so this will move towards like this one. Okay, and because you have selected value of K as 2, so you will probably end up with the 2 clusters only. Okay, and somehow you will move your randomly initialized centroid to some sort of like this, okay? And you can simply refer this as a cluster 1, and the second one is as a cluster 2, right? Let me just manually create this cluster, right? This is like your cluster 1, and this is like your cluster 2, okay? So guys, just let me know, is it like the perfect like the classification or kind of clusters or group we have created? I don't think so, right? The group or clusters, if we pick the value of k as 3, that should be good enough, right? And it should be the perfect visualization, you can say, if you just simply select the value of k, right? So it's very important to identify the value of k. If you end up with the wrong value of k, then you cannot like simply understand the pattern of your data. So you have to initialize the random values of k from that starts with 1 and then followed by the number of cells samples. It's not only with the k value as 2, right? You can give the k value as 3 as well. You can give the k value as 4 as well. Now what about the four clusters, right? It can be like cluster 1, cluster 2, and you can just say this as a cluster 3, like this one, and that one is like, you can just say this as a cluster 3, and that one is like the cluster 4s, like this one, okay? So it's completely based upon the value of k. So you got to know that, okay, it's very important to understand the k value, and k is just nothing, it's like the number of centroid, and number of centroid or like number of clusters, right? So in simple format, we say this as a number of clusters. I hope everyone is getting my point, right? So there is a technique that we initialize the value of k from 1 and then go up to the value of k or whatever the samples we have, right? And then we'll try to calculate the squares or like the errors of the square, right? And we have that error, and we generally refer that error as a within cluster sum of squared error. The okay, in the linear regression, we generally refer the error as MAE, MAC, and RMSE. But when it comes to unsupervised machine learning, na, we have the name of that error as within cluster sum of squared, and it becomes within cluster sum of squared errors. Okay, within cluster sum of squared errors. Now, what is that? You will simply create a clusters, right? You will create a clusters, and whatever the centroid that you have initialized, whatever the centroid, right? Suppose the centroid is like this one, okay? You will check the distance of each value from the centroid. If you somehow apply some sort of wrong centroid, so the distance will end up with the like high distance, and you will definitely get the like highest loss, right? So let me just say this. If the centroid value is far from their clusters, like the cluster is here, but their centroid value is like this one, so the distance between of each these points will be very huge, and you have to take a square of all these distance, right? And then you will simply calculate the within cluster sum of squared errors, and you have to minimize that errors. If you just simply initialize the random value as 1 or like the k value as 1, so you can just check now if I am just simply considering this as a 1 clusters, right? So the squares value or like loss value will be very huge, right? You can just simply check. We need to calculate the distance from each and every points, right? And the loss will be very huge, right? So that is the reason we have to identify the k and then followed by the clusters. If you are creating clusters very close to the points, if the clusters are very close to the points like this one, this is the clusters, so there are no such of like so much movement of points to their centroids, so the square of their distance is like very less, and that is the reason we have to calculate this within cluster sum of squared error to quickly identify if the value of k is changing, how does this WCSS is affecting, right? And the graph something looks like this, right? In the x-axis you have the value of k, okay? The more you increase the value of k, the less the number of like the less the scores value or like the errors value, right? And this is your WCSS, and WCSS is like your unsupervised machine learning within cluster sum of squared error, right? So in this particular graph candidate, what you will get, you will get if the value of k is like if the value of k is 0, k is 1, K is 2. All K is like the number of clusters, 3, 4, 5. All these are the number of K values. And the final value is like the same as the number of samples, or you can pick any n numbers, right? And we know that now if we are not taking any clusters, suppose let the cluster is 0, so the error is maximum, right? So you have to start with the one clusters now. If you are just considering this as a one centroid, one clusters means one centroid, so the distance of each point from this centroid is very huge. So you can say if we are just only considering the one clusters now, so the somewhat error will be like the maximum one, or it's like very huge, right? So what you will do, you can just simply plot all this one like this. Okay, if the value of cluster is 1, so the loss is very huge. If the value of cluster is 2, the loss is some sort of reduced. If the value of cluster is 3, the loss is reduced. If the value of cluster is 4, the loss reduced. If the value of cluster is 5, loss reduced. And then 6, and then 7, 8, and then after you will see the loss somewhat remain constant, right? Okay, if you increase the number of clusters, if you just plot all these points candidate, so you will get to know, okay, this graph some sort of like this. Okay, if you just plot this one, the graph will end up like this one. Okay, and this graph, we generally refer this graph as a elbow method graph, right? What is this graph is all about? This is like your elbow method graph. Okay, elbow method graph. So inside this graph candidate, what you have to identify the value of k na, which one is the perfect value of k. So you can just check where the elbow is forming. Okay, the elbow is forming some sort of like this one. You can just check the elbow. Elbow is like, where is the elbow? This area is the elbow, right? This is the elbow area. And at this elbow area, or you can, some people also say, sir, the elbow is somewhat like this. Okay, but after the elbow, the error somewhat remains constant, right? Where exactly the drastically change, or like the maximum change that you are getting, is the elbow one, right? So if you want to calculate the value of k na, so you can just simply identify, you have to find where is the elbow, right? And we say this as a elbow method in k-means, right? And the interview generally also asks this, what is elbow method in the k-means? So elbow method is like, we will plot the value of squares, the value of errors, and then followed by the k value. K is like the clusters. And where you are getting the elbow is like this area, then you can probably say this, okay, this is like the value of k, and the optimum value of k is like 4, in the same way that we are getting optimum value as like 1, 2, 3, 4. So you can say that the 4 clusters should be there, right? Okay, so it's not completely for this data set, guys. The data set can be different, but we have to identify, okay, we are getting 4 different points now. So it's like the value of k is 4. So let's just consider the final pattern is like the final clusters that we will create is the 4 one. Okay, so in this way you will identify the value of k, and once you identify the value of k, then you can convert your data set into different clusters by applying those clusters values, the first clusters, second clusters, third clusters, and somewhat the 4 cluster here, whatever the data set that we will get, right, based on that. So elbow method simply helps us to quickly identify the value of k, and how you can simply identify wherever you are getting this elbow kind of formation, that is the value of k, right? And this generally can be represented by this as a within cluster sum of square error, and we simply say this as a WCSS error, and then followed by the k value. And k is like nothing, it's a value of clusters, like how many clusters that we want to like generally create, right? These are like my k-means kind of algorithm. I hope everyone is getting my point, candidate. Is there any doubt or any question related to this, guys? Let me know. Tashri, Spurti, and any other candidates, guys? So in this way, we can use this k-means algorithm. So in short, we have to randomly like initialize the centroid. Okay, centroid, and then take mean and move take means and move your centroid towards like what, towards that clusters, and move your centroid towards clusters. Okay, so this is the main use of this k-means clustering, right? And the k is nothing, k is the value of clusters. K is the value of clusters. Okay, And how to identify or calculate the value of k? We can use elbow method. Elbow method is the generic method, right? Elbow method to quickly calculate the value of k by visualizing that the graph, right? So this is the elbow method that you can use, right? So this is all about the k-means algorithm, candidate, right? Now let's just move this to hierarchical clustering. The hierarchical clustering is also very easy one and the good one, right? So in this hierarchical clustering, the hierarchical clustering are mainly divided into two parts. The first one is called the agglomerative and the second one is like the divisive approach. Okay, so let me just write this, the hierarchical clustering. Okay, in this hierarchical clustering, it is mainly divided into two parts. See, if we are saying this as a clustering now, it means this is the unsupervised machine learning. Okay, in this hierarchical clustering, we have two different techniques. The first one is called the agglomerative and the second one is called the divisive approach. Okay, you have to understand any one, right? The opposite is the very easy one. The first one is called the agglomerative and second one is called the divisive approach, right? Let me just show this what exactly this is: agglomerative approach and the divisive approach. Okay, the agglomerative approach, we generally refer this as a bottom up, and the division is like we are just dividing the things, right? It's just opposite of this agglomerative approach, right? Now let's just understand what exactly this hierarchical clustering is. Very easy one, right, candidate? Okay, so let's just consider the data point. Okay, so suppose the data points are like this one. These are like my data points. Okay, like this one. Okay, and we know that if I simply visualize this data point, there is a requirement of two clusters. We can say the two clusters is mainly that is required to create or like to simply represent this kind of data set, right? Now what exactly this hierarchical clustering perform? So it will just simply try to add on the groups, right? We know that now the hierarchical clustering mainly comes with two different techniques. The first one is called the agglomerative and second is like the divisive approach. Okay, so the agglomerative is called the bottom up approach, and it is like very easy. You have to merge the closest points and form a group. Okay, now if you just consider this, right, can I just say this? Let's just take this data set like this one. Okay, so what you are going to data set, let's just keep this only so that we can understand it in a simple way, right? Now you have to merge all the points to form their nearest group. Can I say this, candidate? These data points form a group. So this is like my agglomerative. It's like we are bottoming up. Okay, and let's just say this as a 0.1, 0.2, 0.3, 0.4, and then 0.5, and same as it is 0.61. This one is 7 and 8, 9, 10 and 11 and 12, right? 11 and 12. Okay. Okay. So in this agglomerative approach, candidate, what we have to do, we have to create a group of simple like closest vectors or closest data points. Okay. So what you can do, you can just simply say, okay, sir, this can be a one cluster. So we are combining 3 and 4 together. Okay, very good. So this can be also clusters 1 and 2. Perfect. So this can be also clusters. Perfect. So we are combining up, we are bottoming up the approach, right? Okay. So this can also be a clusters like this one. 7 and 8 is like the clusters. Okay. And this can also be the clusters are like 11 and 12. It's like 6, 7, 8, 9, 10 and 12. You can also say instead of this one, sir, 11 and 12 is also clusters. And you can also say, sir, this one is also clusters, right? Okay. So we are bottoming up the approach, right? And this is called the hierarchical clustering. In this clusters, what you can do, just do, if you just create a clusters now, you have to merge all clusters into one. You have to repeat this process until you get the final clusters, right? So you are just combining this as cluster, this as cluster, then this as clusters, this as cluster. This is like the individual clusters. This as clusters. This as clusters like this one. You can also say this as, okay. You can also say this as clusters, right? Like this one. Okay. And then this one as clusters. Okay, and then this one is clusters as well, and then finally this one is cluster, and then finally this one is the final clusters. So we are just combining the closest data point into a clusters, and that is called the agglomerative approach. In this agglomerative approach, we are bottoming up and merging the closest point, and divisive is just the opposite of this. Okay. Okay, but the problem is we have to identify the number of clusters, no, candidate. So we know that the two clusters was enough to understand this kind of like distribution. Okay, so how to particularly get the value of two? So for that you have to create a graph using this kind of clusters, right? And this, we generally refer this graph as a dendrogram graph. Okay, we'll say this graph as a dendrogram graph. Okay, I'll repeat the name again. This graph is called the dendrogram graph, right? Now what you will do, you will simply first plot all the points like point 1, point 2, point 3, point 4, and then followed by their Euclidean distance, like distance 1, distance 2, distance 3. All these are like my Euclidean distance, and you know that now Euclidean distance are like the distance formula that you can use. All these are like, let me just write this as a Euclidean distance and then followed by the points. Okay, this one is like point 1, point 2, point 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We have 12 points now. Now what you have to do, whatever the groups that you have performed and then followed by their distance, you have to create a dendrogram, and the dendrogram is something look like this. Okay, the 3 and 4 points are closest together. So where is the 3 and 4 point? So you will just simply pick point 3 and 4, and whatever the distance that you will get, you will create the dendrogram like this. Suppose we'll get the distance like this one. Okay, between 3 and 4 points, these are the distance, right, you are getting. Okay, now 1 and 2 is also a clusters, so just simply identify the 1 and 2 is like the distance, like we are getting the distance like this. Okay, and 1, 2, 3, 4 is also a cluster, so you can just simply combine this as 1, 2, 3, 4 is also a clusters, and then whatever the height that we are getting, candidate, is followed by their distance value, and you know that the distance is like the Euclidean distance. Okay, now just come to this point. Okay, 7 and 8 is also a cluster, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Yeah, we have to combine this to 5 now. 1, 2, 3, 4, and then 5, right? Let's just combine this to 1, 2, 3, 4, and then followed by the 5, right? These are like 5, and you can simply combine this one. This one is also the form of clusters that you can form, right? And then followed by 6, like 7 and 8. So just simply pick the 7 and 8, and then you can just quickly see whatever the distance that you will get now, guys, you have to form the distance. Okay, and then followed by like 11 and 12, and then 10 and 12, or like 11 and 12. You can also connect 6, 7, 8, 9, 12. It's 11 and 12, or like 10 and 12. So you can just say this as 10 and 12 is connected, and 10 and like 12 is also connected. Okay, and 6, 6, 7, 8. See, it's like 6, 7, 8, 9. Okay, so 6, 8, 9 is also connected, right? So 5, this one is like 1, 2, 3, 4, 5, and 6, 8, 9 is connected to 6. Just simply pick this 6, 7, 8, 9, and just combine this to this one, right? This is like your clusters. Okay, these are the dendrogram that you will create. Okay, and then finally followed by the complete clusters. It's like 6 to 11. Okay, so just simply pick this as 6 to 11. Okay, and you have to calculate the distance, right? Each distance, and then followed by the all complete one, 1 to the complete one, and you know that the 1 to complete one is like this one, 1 to complete one, and you will get some sort of data like this. Okay, so whatever the graph that we have created, candidate, these are called the dendrogram graph. Okay, I hope everyone is getting the point, candidate. This is called the dendrogram graph, right? Dendrogram, and this dendrogram helps you to, it's like a tree kind of a structure, and it helps you to simply calculate the closest point, and then based on this closest point now, then you can probably calculate the number of clusters. Now how to identify the value of k, because to identify the value of k is very important now. So how you can simply identify the value of k, this one is very important now. So for that there is a generic formula, or like a generic concept you can simply perform. You have to find the longest, you have to identify the longest vertical line. Okay, but we have some sort of constraint. that longest vertical line must not be cut by any horizontal line. Okay, it must not be intersect by any horizontal line. Okay, whatever the line that you will get candidate, it must not be cut by the horizontal line, any horizontal line. If it is cut by horizontal line, then you have to ignore that vertical line. Okay, if you are satisfied with this one, then you can probably count the number of cuttings and then you can pick the value of k. Okay, let me just check this, right? If I'll consider this as the longest vertical line, suppose, so you can just check na ki any see any of the lines must not particularly like simply intersecting all these lines, right? So you can just say if I am considering these lines na, so any of the value, it could be like any of the values like this one, it can simply like intersect the values like this. If you just draw a horizontal line, right? If I just say simply pick one, this as the longest line, so this line will eventually cut this line like this one. Okay, if I'll just pick this one as the longest line, so this line will cut this to intersect line. Okay, if I'll pick this one as the longest line, so this will simply intersect all these my longest vertical line. So you cannot particularly consider this like this one. Okay, if you just pick this, it might be chances it can like intersect by this line also. So you have to identify the longest vertical line. What about this one? If you just simply consider this, this can be intersect by this line also. So now you can just say that, okay, if I consider this as the longest vertical line, this can be intersect by this one. If you just draw horizontal line, right? What about this one? If you just consider this as a horizontal, like the vertical line, there is no such line that can be intersect. See, this is the actual line. You cannot pick this one, right? Okay. If you just consider this as the vertical line, we are not getting any line that generally cutting this line vertically, right? So you can just say if you are getting this line, now let's just simply create any random line between this vertical line. Okay, just pick any random line between this vertical line, and whatever the vertical cuts that you are getting, these are the clusters. Okay, we are getting the cut here, the first cut and the second intersection. We are getting two intersections now. Now you can simply say to just simply create a clusters of this kind of data, there is only requirement of value of k. Okay, and how to identify the value of k? You have to create a dendrogram for this, right? Okay, okay, candidate. I hope everyone is getting the point, right? You can, if you get the highest vertical line or like the longest vertical line, then you have to draw a random parallel line, and whatever the vertical line it's cutting, you will particularly pick that k values, right? Because it's cutting two times. The first one is here and second one is here. So we will pick the value of k2 here, and you can just simply understand if you want to create a clusters of this kind of visual, there is only two clusters requirement. The first one is like this clusters, and second one is like the this clusters. Okay, and that's how you got the value of k, candidate. And this is called the hierarchical clustering. The hierarchical clustering is like we are combining the data in the upward direction. This is called the bottom up approach, right? And the reverse approach is exactly similar. The reverse is like the divisive approach. Instead of combining, you will first create a cluster and then you will create sub cluster inside all this, right? And the downward approach is called the divisive approach. The upward approach is called the agglomerative approach. So interviewer generally ask you to explain the unsupervised machine learning, and inside this unsupervised machine learning, this will like the interviewer generally ask you to simply explain the agglomerative like hierarchical clustering and the divisive hierarchical clustering. I hope everyone is getting my point, candidate. Is there any doubt related to this, guys? Just let me know. Class, anyone? So in this kind of hierarchical clustering, we have to create this kind of dendrogram, and this dendrogram is very important to simply identify the value of k. Now let's just understand the value of k. You cannot pick this one because you are getting the, if you just consider this as the longest vertical line, so you will cut by any of this line like this one, right? So we can only see, we are not also take this as a line because it will be cut by this one, right? So you can take this one and then you can create a distance, and then followed by the intersection, you will pick the value of k, right? So this is all about the hierarchical clustering, candidates, right? Now, what about the DBSCAN clustering? This DBSCAN clustering is very important, right? This is the third type of clustering that you can refer. Inside this DBSCAN, this one is very important and easy as well, right? Let's just first understand the full form of DBSCAN. The DBSCAN is like density based. You have to understand this word, density based and spatial clustering of application with noise. See, the problem with this K-means and hierarchical clustering now, it is very sensitive to the outliers or unnecessary data point that we are getting. Suppose we are getting one data points like here. Now just let me know which cluster this belongs to, right? This is my noise data point. So K-means and hierarchical clustering are not very comfortable with this noisy data. To eliminate that kind of noisy data, you have to use this algorithm, and that is called DBSCAN algorithm. And DBSCAN algorithm is like the density-based spatial clustering of application with noise. And it's very robust to noise. Robust to noise means it can simply eliminate the noise, right? It know that this algorithm knows how to eliminate the noise and how not to pick the noise for their final prediction value kind of, or for any final clustering kind of things, right? So in the final concept, we generally use this, and this DBSCAN is also very popular to predict non-linearity kind of data, to predict or to create clusters of non-linearity, to create clusters of non-linearity, right? Non-linearity, we will use the DBSCAN. We will use the DBSCAN, right? And you can just check now. Just go to this. These are like the non-linearity data, right? And if you want to form this kind of clusters now, like the cluster one, this is not like in a linear form, right? It's like the non-linear form, right? So you can use the DBSCAN algorithm. This DBSCAN algorithm generally are very good to simply create a clusters like this one, right? Now let's just understand what exactly this DBSCAN is, okay? Let me just delete this. So DBSCAN is very important one, right? Inside this DBSCAN, let's just take a help of this Wikipedia article. You have to understand three terms, and the three terms are like DBSCAN Wikipedia. Okay. In this DBSCAN, we have three different terms candidate, and the three different terms are called all these points, okay? The main point, or like the boundary point, and like the noise point, okay? We have to pick that one, okay? So let's just take this example of this one. You can copy this image. Okay. And see, this is like the classification is done, not the classification, the clustering is done with the help of DBSCAN, okay? Before you start this DBSCAN, you have to understand three different terms. The first one is called the core points. Boundary points, okay? And then noise, and then minimum points, and then radius, okay? These are the key terms that you need to understand, okay? And we refer this radius as the epsilon, okay? So let's just take a screenshot of this. This radius is nothing, just a epsilon, right? This one, okay? Let's just paste it here, right? Now, what is core point and what is minimum point? This minimum point and this radius are called the hyperparameter. These are like my hyperparameter. So let's just pick the minimum point value as 4, okay? And the radius value as 1 unit. The radius value is 1 unit, and we refer this radius as a epsilon, okay? We refer this radius as a epsilon, and the minimum point value is 4. Now what you will do, you will just simply pick any of the point, okay? Just pick any of the point like this one. Let me just increase the size of this. Suppose this is my point. Now there is a definition for the core point. If any of the point, can you understand this thing, right? If any of the point is surrounded by at least 4 points, at least 4 or more points, then you will consider this point as the core point. What is that, candidate? If any of the point is surrounded by 4 points, right? At least including that point as well. So you can create a radius of 1 unit. You can create a radius of 1 unit like this. And then you will simply consider this as a core point. I hope everyone is getting my point, candidate. What is core point? The core point is like if any of the point given by the following radius is like 1 unit, and if you are getting the 4 point inside or like 3 point inside this and including this original point, if you're getting 4 points value at least or more than this, then this point we generally referred as a core point. Okay. Now what about the border boundary point or like the border point? Okay, so we say this border point as or like the boundary point if the value of any of the point is less than 4. Okay, if this is my point and we are getting the surrounding point as like this. Okay, now we are not getting the surrounding point as 4 or like more than 4, so we will simply refer this as a boundary point or like the border point. Okay, so let's just create a cluster here. This is like my border point. And how to create a radius? We can use the epsilon value as like the radius one. So this is like my boundary point or like the border point. And what about the nose point? The nose point are like which is outside the border point or like which is outside the core point, which does not fall inside any of the point, which is single itself. Is called my noise points, right? So this DBSCAN generally try to work on 3 different techniques. It's like core point, boundary point, or like border points, and then noise point, and then followed by 2 hyperparameter. The first one is minimum point, and second one is the radius. Now, why we are considering this red as a core point? Now let's just understand. In this particular this one, why we are considering this as a core point? Because this is point 1 and it is surrounded by 3 different points, 1 point, 2 point, 3 point, and finally it becomes 4. So that is the reason we are saying this as a core point. Why we are saying this as a core point? Because if you consider this, it is surrounded by 1, 2, 3 and including this 4 point. So we are again referring this as a core point. Then what about this one? Again, it is surrounding with 1, 2, 3, 4 and including this also 5 point. That is the reason we are considering this as a core point. What about this one? 1, 2, 3 and 4. That is the reason it becomes core point. And in this way, all these red one becomes the core point. What about this border point? Why we are considering this as a boundary or like the border point? Yellow one. Because if you just pick this one, now, it is surrounded with 1 and 2 points only. And if any points is surrounded with less than 4 points, you will simply refer this as a boundary or like the border point. That is the reason we are simply referring this as a border point, right? And this one also, this surrounded with. Okay, now what is the value of this circle or like the radius of this circle? This is somehow we decided by the epsilon parameter. Okay, if you work in this like DBSCAN algorithm, there is a parameter that is called the epsilon. Epsilon is nothing, it's like the value of the radius that you will pick, right? Let me just show this, right? This is the value of the epsilon value. Okay, you can just simply check this radius value. Radius is like the epsilon parameter, and this is the EPS. EPS is like the epsilon. Epsilon is like the radius that will help you to create the like boundary or like the circle to simply eliminate the core point or like the border point, or to simply identify the boundary point, border point, or like the core point, right? So can it, in this way we can identify the core points, border point, and whatever point that left with the single value will be considered as a noise point. So this DBSCAN is completely based upon the density based, and that is the reason we are comparing the, or like we are referring this as a density based spatial clustering of application with noise. And why we are saying this as a with noise? Because it can simply eliminate the noise data. If you just simply create a circle of 1 epsilon, you will not get any of the point, right? That is the reason you are considering this as a noise point. It's not like to take the epsilon or like the radius as 1 centimeter. This is 1 unit, and it is decided by the developer or like the ML engineer how many points or like how minimum point we need to consider pick for the core point, and then followed by the border point. Okay, so this is all about for the like DBSCAN based algorithm. And in this DBSCAN hierarchical clustering, K-means clustering, all these are useful to particularly simply understand the unsupervised machine learning, right? So let me just quickly give you the recap. The K-means is like you have to randomly initialize the centroid value. Okay, now let me just take the final screenshot of this K-means. Okay, so in this K-means, you will just simply move your centroid toward the mean of the data set. Okay, this is like the K-means algorithm. In the DBSCAN algorithm, you will identify the core point followed by their minimum value, minimum point value, and epsilon value, then followed by border point and then the noise. And in the hierarchical clustering, you have to follow the bottom up approach or like the divisive approach. It's like the agglomerative clustering or like the divisive clustering, where you will create the dendrogram. I hope everyone is getting my point, right? So class, in the next class, right, today we have covered this one. Right now in the next class we will create the practical implementation of this with some sort of data set, and then we will understand how to evaluate these models as well. Okay, so this is all about the theoretical concept of all this kind of like unsupervised machine learning. And we also know that if you want to find the value of k inside the k-means clustering, you have to use the elbow method. Elbow method is some sort of like this one. Okay, and if you want to find the value of k in the hierarchical clustering, you have to create the dendrogram, and this DBs can by default identify the value of clusters, right? Because it's completely based upon the core point, border point, and the noise point. So candidate, this is for the today. This is all for the today, right? I hope everyone is completely understand the unsupervised machine learning, how to simply create the model, but to practical implications of all these things, we'll simply pick the data set from different sources, and then we'll apply all the algorithms in those data set to create the clusters. Now simply understand the clusters is not the kind of the outcomes that we will predict. It's just a set of same frequency or like the same set of features of data set, and we refer this data set as a clusters, right? There is no such Y prediction that we have to perform, but we have to give them color coding to simply refer this as a clusters, right? And that is the main objective of the unsupervised machine learning, right? So guys, this is for the today. We have already like covered this topic yesterday, and we quickly understand the different types of unsupervised machine learning. Okay, because so this is the theoretical class, so let's just implement the practical class tomorrow, and I'll share you the link with you. This is the theoretical one only. You have to take a reference from the notes or like the meetings so that you can understand the elbow method or like the dendrograms and like the core points, noise points, and so on, right? Let me just share with you. And this is for the today. So guys, any doubt or any question, just let me know. I don't think there should be any doubt. Can it? If it is, just let me know, or shall we close this one? Candidates, I think it's good to go, right? So you can take a reference of the video recordings that already been shared, and this one also can be shared, right? Then let's just connect tomorrow. So wish you all the best for the today. Okay. Just close this recording. Let's just connect tomorrow.